Crispr, a potential cure for blindness and a variety of other diseases. This is a really exciting video. Be sure to stay tuned for all of the great information. Hey everyone, it's Matt. Welcome back to another Blind to Billionaire video, and today's video is a really exciting one. We're going to be talking about some advancements in the medical field, otherwise known as CRISPR. So I'm actually here with Corey right now, and do you have anything you want to say?
Just hi. Welcome.
Yeah, so we're really excited about this. There was actually an article in the Minneapolis paper on March 8th, which is Sunday, and we want to talk about it because it's about CRISPR and it's just really exciting. So what we're going to do is just to give you a little bit of background on what CRISPR is, I'm actually going to have Corey read an article, not an article, but right off of CRISPR's website telling us basically like what is CRISPR, right?
Yes.
So Corey's going to read that article or the little tidbit here for us and let us know like what is CRISPR.
Okay, so this is from the CRISPR website. So it's CRISPRTX.com. For CRISPR Therapeutics. And what they basically say about what CRISPR/Cas9 is a specific, efficient, and versatile gene editing technology where we can harness to modify, delete, or correct precise regions of our DNA. And another thing it says is that the CRISPR-Cas9 edits genes by precisely cutting DNA and then letting natural DNA repair processes to take over. So that's kind of, I feel like can be really, really complicated because I'm not a geneticist.
Yeah.
And so I think that there's a complicated component to all of this, but we just wanted to give a tiny bit of background. Basically, CRISPR is a gene editing technology. So this is a type of a treatment. And actually that can be used for a variety of things, not just treating blindness, but treating
like
a
whole host
of things.
Diseases. Yeah, it's really interesting is they call it a technology. It's literally like a technology on the molecular level, right?
It is. Yeah, but it's a gene editing platform into therapies to treat like blood diseases, cancer, diabetes, and other diseases. And basically, it's this company that is working using this technology to treat a variety of different things.
Yeah, and what's really cool about it is blindness is on the spectrum of something that this CRISPR could potentially treat.
Yes.
Yeah, I mean, it's really exciting. So, do we have anything we want to discuss about that?
I don't think so, except that the reason why it's in the newspaper is because they tried it for the first time.
Yeah, so on March 8th, like I said, in the Minneapolis paper, there was an article written about it saying that they actually installed this CRISPR into the very first human patient. So I'm actually going to have Corey read the article out of the Minneapolis paper now, and this is really exciting stuff.
Yes, and then I'm going to just give credit, I think is the best choice. This article was written by Marilyn Marchioni, so that I don't get...
And this is in the Star Tribune paper out of Minneapolis on March 8th.
Yes, so it's a very short article. I'm going to read it so that you guys have the information.
Yeah.
Okay, scientists... So the article is titled CRISPR Used in Body for First Time, Marking a New Frontier. Scientists say they have used the gene editing tool CRISPR inside someone's body for the first time, a new frontier for efforts to operate on DNA, the chemical code of life, to treat diseases. A patient had it done at the Casey Eye Institute at Oregon Health and Science University in Portland for an inherited form of blindness, said the companies making the treatment. It may take up to a month to see whether it worked to restore vision. If the first few attempts seem safe, doctors plan to test it on 18 children and adults. In quotes, "We literally have the potential to take people who are essentially blind and make them see," unquote, said Charles Albright, chief scientific officer at Adidas Medicine, which is developed with treatment from Dublin-based Allergan. I know I'm butchering names. I'm doing my best. Dr. Jason Commander, an eye surgeon at Massachusetts Eye and Ear in Boston, another hospital that plans to enroll patients in the study, said it marks, in quotes, a new era in medicine, unquote, using a technology that, quote, makes editing DNA much easier and much more effective, unquote. The people in the study have Leber congenital amaurosis, caused by a gene mutation that keeps the body from making a protein needed to convert light into signals to the brain, which enables sight. Scientists can't treat it with standard gene therapy, supplying a replacement gene. So they're aiming to edit or delete the mutation by making 2 cuts on either side of it. The hope is that the ends of the DNA will reconnect and allow the gene to work as it should. So that's the article.
Yeah.
I mean, this is really a big deal. So, and I'm not trying to take over the talk, but I just want to kind of clarify. So CRISPR can be used, this technology, in a variety of ways. And the first time they're using it in a person is to help somebody who is blind.
Yeah.
I mean, this is so
really,
cool.
really
We are lucky to like have this technology available, and we just hope it helps people.
Yeah. I mean, that's really exciting to think. So CRISPR has been in the news and it's been around for, I mean, we heard about it a few years ago, but I mean, to think that they're finally at the stage now where they're implementing this into human research. I mean, that's amazing. I feel like that's what takes the longest amount of time, is just getting it to human trials. So hopefully this person, that the first patient starts to see some kind of progress, or at least they can see that it's safe. Because if they know that it's safe, they're going to start doing it on, like they said, 18 other children and adults.
Yeah, I mean, this is very cool. And I read in a different source that it's about an hour. It took an hour under general anesthesia. And it's a fairly non-invasive procedure in your eye, is my understanding from what I read. And so it's not super scary.
Right.
You know, like maybe, like if you were nervous about getting something like this done.
Yeah.
You know, so I think that that's really cool too. But it's just, we wanted to share this because we feel like this is always the information that we're waiting for.
Yeah. I mean, this is really, really powerful, because you just never know. I mean, this could be the answer for a lot of us. We just don't even know. I mean, I've said this a few times in the channel, but I mean, I don't feel like it's a matter of if we're going to have some type of treatment. It's more like a matter of just when is it going to happen.
Exactly.
I truly believe that there will be some type of treatment for us. I truly believe that. I felt it that way for years.
It does seem,
who knows?
Like CRISPR, we've been kind of banking on this for a few years, this CRISPR.
Realistically, before this, I mean, the only two things we had to bank on were either gene therapy, which is basically just stopping the progression of vision loss.
And that's Luxturna.
Yeah. Or stem cell research, which there's a ton of controversy about that. And it's hard to make any progress because, you know, it's so controversial. So
in the United States, there's so many rules.
In the United States, anyway. So this could be, I don't know, the replacement for both of those.
So it's really cool. And so it's for people currently, they're doing this on people with LCA. And usually stuff translates. So,
yeah.
I mean, we are so grateful for people potentially who have LCA who could potentially someday get to have this treatment. But for other people who don't have LCA, that doesn't mean that you won't be next.
Yeah, I wouldn't, if you don't have LCA, is that what it is? LCA?
LCA.
Yeah, I wouldn't worry about it. Like
congenital.
if you're someone like me as RP, I wouldn't worry about it one bit. I mean, this is really exciting. I like to typically relate advancements in the medical field to technology. Think back 15 years ago. What was the first smartphone? It was like a BlackBerry, right? Or something like that?
Oh,
or
smartphone, yeah.
Smartphone. It was maybe like a BlackBerry or something like that. All you need is someone to break the barrier and get through to say okay, we can do this. And then you have all these other companies flood the market basically, saying okay, you came up with the concept, you broke the barriers, and now look what we can do. And here we are a few years later sitting with the most amazing iPhones you could ever imagine.
It's just amazing.
It's amazing. So whether it's in technology or medical, I mean, I feel like it all translates, but I always like to think about all the advancements from a technical technology standpoint, which is, all you need is somebody to break through the barriers and to find something, and then going from basically nothing to, what am I trying to say? Going from no concept.
Starting from ground zero to how great it can be, right?
Yeah.
I mean, it's limitless.
Yeah, but I feel from now on, moving forward, advancements will probably happen potentially much more quickly.
Something else I wanted to just kind of glean from the article for people who are listening is that, like they said, this is the first time CRISPR is used in the body. There's different ways they can use CRISPR, is my understanding. Like they can do out-of-the-body treatment. There's different types of things. But what's cool is that though the Leber's congenital amaurosis people technically would be benefiting first potentially from this, once this treatment seems safe and kind of works, they can use this hopefully in the body. And I'm just kind of like piecing together what I'm reading. But if there's other things they can treat, and if this works well and is safe, there's like, I'm sure a lot of other, like they said on the website, there's other diseases that can hopefully benefit.
Yeah.
But it happens to be that this blindness from Leber's congenital amaurosis is like the first thing that's being tested. So like Matt's saying, in technology, any advancement's good. In medicine, it is the same thing. So even if one area is being worked on, CRISPR's being used in one area, it can help so many other areas. And that's something we have to be really grateful for too. Just because your specific area isn't being worked on, it is being worked on kind of as in a secondary way. And
another thing that's
so
really exciting. Yeah, that's really important. Another thing that's really exciting about this too is if this starts to work on patients who have vision loss, and there's so many other applications for potential cures of diseases, they're going to get just a massive amount of funding. It's going to be ridiculous.
That's actually a really good point, Matt.
From a funding standpoint, I wouldn't be surprised at all if the government steps in and starts throwing a ton of, like, billions of dollars at this, because if this could be the kind of the cure-all for a lot of different things, I mean, they're going to have so much, like, a massive amount of funding. It's just going to be ridiculous. And that's like the biggest holdup on a lot of this research is they run out of funding, or they don't have the funding to move forward. But if this is kind of like a one-size-fits-all kind of cure for all these different diseases, I mean, it's going to be incredible. So really exciting.
It's very cool. And I don't know how it's currently being funded.
Yeah.
To be fair, we just talked about the government being funded. We don't know that information, so we don't know how it's being funded. It could be government funded. We don't know.
Probably not at this point. I'm not sure, but you better believe if they get behind something, funding. It will get tons of money behind it.
The other thing I always like to tell, like I always think about, because I know people get like really nervous about this, and I don't know, Matt, if you would agree, but like with Luxturna, and that's for RPE 65.
RPE
is that
65?
RPE 65? So if you have RPE 65, Luxturna might be an option for slowing the progression. Anyways, but it's like, it's like $1 million for the treatment. You know, people get like really, really nervous. Like, I could never afford the treatment. I think that if you are somebody who qualifies to have something done, I feel like if there's a will, there's a way. Like, and maybe I'm naive, but I feel like if there's a treatment for you for this, I feel like it will work out. Yeah. I mean, what do you think, Matt? I just want to speak to that because I feel like people get caught up like, well, I could never pay $1 million to have this done. It's like, well, you're not paying $1 million to have this done, is my understanding. But Matt, can you speak to that?
No, I completely agree. I feel like funding or like money to like pay for something like this would be the last thing you should worry about. Like, seriously, don't ever worry about that.
And I'm not trying to sound like first world problem type of, I mean, I'm not saying it like that. I'm just saying that I think if there's a treatment. Yeah, exactly. I mean, if there's a treatment, there will be a way for you to get it done. Yeah, insurance companies work together. It's a thing. I mean, there's so many different options. Yeah. So many different options. And if you are ever someone, I mean, Matt and I have not talked about this, but if you're somebody who is qualifying for something and you don't understand how to get it paid for through your insurance and whatnot, I mean, we can't personally help you, but I mean, I feel like don't give up. Yeah. Don't give up. Yeah. But like, there are resources, out there. But I mean, that's going to be that'll be a video for sometime in the future. Yeah. But again, yeah. But I do like to mention that because I feel like that comments are going to come in like, oh, I can't afford it. And it's like, well, trust me, you can afford anything. Let's cross that bridge when you get to it. Yeah. I think the most important thing is thank goodness for these genetics scientists, and I mean, they are like making a huge difference in the world. Yeah. Yeah. I mean, like, I'm so grateful. I'm so grateful for these people who work at Crispr Therapeutics. Yeah, it's these people that, I mean, they're absolutely brilliant. Mm-hmm. If it's not for them finding a cure, I mean, there would be no hope for us. So I mean,
it's these people that are giving us potentially our vision and everything back. But I mean, literally, like we just said, the last thing you should ever, never ever worry about money. Seriously.
Not for this.
Not for this.
This is different.
Yeah.
I also just
be grateful for these people that are spending their time to do this, because it's
crazy.
I mean, it's just crazy what they're doing for us.
And I also want to say that if you are interested in visiting this Crispr website, I would encourage people to do that independently. I have been reading through the website, and we've read articles and we've read about this. I know I don't understand it, how it works. Would you agree, Matt? Like, we don't understand.
No,
we don't
understand
know how
this.
it works. We don't really get what CRISPR is, because we're just reading off of a website. We don't understand genetics, and we don't understand this process.
Yeah, but anyway,
we know that it's out there.
The website, again, if you want to check it out, CRISPRTX.com.
Yes.
So it's like CRISPRTX.com.
Yes. So we will put that in the link below, but check it out. If you can read a ton of articles. We happened to pick the one that was from our paper, but I also online, there's a ton of articles too that are the same type of article, just written by different people about the same thing. So definitely check out this information. But we want to provide value to you all, and this hopefully is valuable.
Yeah.
I mean, we're like thrilled. This is what we want to tell you. This is what our channel should be about, is like awesome things that are out there in the world.
I'm excited to see an updated article in roughly, let's just say, like 4 to 6 weeks. Hopefully they give us some kind of update. Maybe not in the local paper, but hopefully like on the CRISPR website or somewhere, they give us some kind of update, like, how's that patient doing? I want to know.
I mean, this person could be one of you.
Could be.
I mean, you could be watching this video being like, that's me. I just can't say anything because, rules.
Yeah.
I mean, this is like, somebody's like, they might be seeing soon.
Yeah. It's exciting stuff. But anyway, that's all we have for you today. Again, I just want to say this is not medical advice in any way, shape, or form. So just wanting to know, like, just relaying some of the information that we found. Really exciting. We'll give you any updates we find in the next, following weeks coming up. But this is really cool.
We're so happy.
Yeah. It's amazing.
Yes. Thank you all for being here.
Yep. Thanks, everybody. We'll catch you on, Thursday?
Yes. See you on Thursday.
All right. See you, everybody. Bye.
You can't wait to see me now, 'cause lately you've been feeling down.